You know that feeling when you're in the middle of a home project and suddenly you just hit a wall of technical jargon? It's the worst. Well, today we're going to solve one of the most common puzzles in home wiring. What is the deal with feeders versus branch circuits? Let's figure this out once and for all. And this whole mystery really starts with a super simple question from a forum user named Celtic. They asked, is a feeder a branch circuit or is a branch circuit a feeder? Are they synonyms? And look, this question trips up so many people. Are they just interchangeable words for the same thing? The answer is a big, fat no. And honestly, knowing the difference is absolutely critical. So, what was going on with Celtic's project? It was supposed to be a really straightforward wiring job for a small home addition. Just a couple of new circuits for some lights, a few outlets. Should have been a piece of cake. But then, an official stepped in and made a demand that just didn't make any sense. All right. To crack this case, we have to start where any good investigation does, with the official language. So let's put on our detective hats and decode the actual definitions, straight from the National Electrical Code.
Okay, so you look at the official definitions side by side, and bam, you can see right away why this is so confusing. A branch circuit is the wiring after the final breaker. A feeder is the wiring before it. I mean, they sound almost exactly the same, right? But that one little word, before versus after, that changes literally everything.
Let's break this down into something that makes sense. Think of a branch circuit as the local street that leads right to your front door. It's the very last leg of electricity's long journey. Power leaves that final circuit breaker in your panel, travels down that specific branch, and boom, it powers up your toaster or your reading lamp. It's the end of a line, the final destination.
Now, a feeder. A feeder is the electrical highway. It's a big, heavy-duty cable built to carry a ton of power from one major point to another, like from your main panel down in the basement all the way out to a smaller sub-panel in your detached garage. See, it doesn't power your outlets directly, it feeds another panel, which then has its own set of branch circuits.
And this is where forum user Infinity just hits the nail on the head. They said the key is the OCPD. That's the technical name for your circuit breaker or fuse. Here's the deal. A feeder has a breaker at the start and a main breaker at the subpanel it's feeding. It's protected at both ends. A branch circuit, it only has that one breaker at the beginning. Okay, definitions are one thing, but they can be a bit dry, right? What we really need is a simple mental map so we can trace the path of electricity. And luckily, another user on that forum gave us a brilliantly simple way to do exactly that. So this user, Charlie B., laid out this totally foolproof 3-step guide. It goes like this. 1. Start at any outlet in your house and trace the wire back to its breaker. That whole run, that's your branch circuit. 2. Go outside and find those massive wires coming from the utility pole to your main switch. That's the service. So what's left? 3. Any wiring that runs between those 2 points, between the service and the branch circuits, that's a feeder. It's really that simple. And here's that whole journey laid out visually. Power comes in from the utility, through the service wires, and hits your main panel. From that main panel, a feeder might run to a subpanel somewhere else. And then finally, from that subpanel, a branch circuit makes that final little hop to your outlet. If you can picture this flowchart, you will never get them mixed up again, I promise. All right, we've got the definitions down, we've got our map. Now we can finally go back to Celtic's original problem and deliver the verdict. Let's solve this thing. So after all that, what did the official actually tell Celtic? Okay, you're not going to believe this. In Celtic's own words, hold on to your hat. The explanation was that it is a feeder. Can you imagine? He was completely baffled, and now that we know the rules, we can see why. It makes absolutely zero sense. Okay, so now it's your turn. Applying our journey of power map and everything we just learned, what's the verdict? What was Celtic actually installing? Was it branch circuits or was it a feeder? Let's break down the evidence like real detectives. The wires started at a final breaker in an existing panel. Check. They ended directly at outlets and lights. Check. And the crucial part, there was no subpanel anywhere in between. So the conclusion, it's crystal clear. These are branch circuits, without a single doubt. Case closed. So you have to be asking, why on earth would an official make such a basic mistake? Well, the most likely culprit is a very specific rule in the National Electrical Code, NEC 215.5. This rule is all about the special diagrams you need for feeder installations. And let me tell you, it's a whole other level of paperwork and planning.
Just look at this list of what a feeder diagram needs. You have to show the building area in square feet, the total calculated load, the demand factors you used. I mean, this is serious engineering stuff. So by misclassifying these simple little branch circuits as a feeder, the official was trying to apply these super heavy-duty rules where they just didn't belong at all.
So, you can see this was way more than just a little mix-up on a forum. Understanding this distinction has real practical consequences for any of us who are planning a project around the house. So, why does this all matter? Well, first, safety. Feeders carry a lot more juice, so you need to know what you're dealing with. Second, code compliance. You get this wrong, your project's going to fail inspection. Period. It also affects how you plan out your work, and maybe most importantly, it lets you speak the same language as your electrician and your inspector. That way, you don't get forced into creating these crazy complex diagrams for what should be a simple job.
You know, every single wire in your house tells a story of safety and planning. Knowing the difference between a feeder and a branch circuit is like knowing the difference between a highway and your own driveway. It's that fundamental to understanding the whole system. So the next time you're thinking about a project, you'll know exactly which part of that electrical map you're working on.